Welcome back to Just Another Solar Podcast with Luke Beattie. That's me, Karl Jensen. G'day, Karl.
Luke, how you going today? It's been getting pretty hectic towards Christmas for everyone.
And we've got Nigel Morris, industry legend.
G'day, fellas. How's everyone?
Busy.
Busy. Yeah. There's plenty going on, isn't there?
There's lots going on. So in the media this week, of course, we've smashed another pile of renewable energy records. And I think the data said that we're 38.5% average renewables on the eastern seaboard anyway, which is pretty amazing. I think we're leading the world.
We're definitely leading the world. Yeah. The penetration, this is like the records are getting boring now. There's just another record every day, it seems, about, penetration of this and interestingly, I don't know if you saw, but the one that came out yesterday, we were at like 80-something% penetration at a peak time in New South Wales, but there was about 17% curtailment. And so if you put the curtailment back in, we would have been over 100% penetration in New South Wales. So, there's still a hell of a lot of curtailed energy out there that we've got to find a way to cut loose as well.
I also met some amazing people. Dr. Keith Kickett from the University of Adelaide, PhD, so on and so forth. And he pointed out that whilst we're not considering it at the moment, our grandkids will be stripping CO2 out of the atmosphere. And of course, if you look at the cost of doing that, it's staggering next to, our cost of putting it there. So that's definitely raised our awareness as to what needs to be done.
What a wild thought. My grandson was up visiting in the last week or so, and I got another one on the way. So it's kind of scary to think that that generation are going to have to deal with a whole new set of problems that we're creating right now.
It's pretty hectic when we're allowed 50,000 tonnes in order to stay under 1.5 degrees, but by all accounts, we're going to miss it by a fair bit.
Well, in a similar vein, I got an invite from our local member of federal parliament to come and meet the Shadow Climate Change and Energy Minister last week, Ted O'Brien. So that was a really interesting chat. So he was talking about the small modular reactors, the nuclear reactors that the Libs were pushing. And I said it's very...
pushing off a cliff, according to the press this week, right?
That's right. Well, that was 2 days afterwards. So this is going back to Tuesday last week. So I chatted and I said, it's very interesting you put these forward. The only way there could even be a business case in the US in the first instance was under the US Inflation Reduction Act. So production tax credits for these new generation sources. And I said, it's also very interesting. If you'd like to install these small modular reactors, one of the requirements is for us to bolster the network, just like the Rewiring the Nation, which the Liberals have been opposed to. And one of the Liberal members who was there piped in and said, yep, I'm very concerned about the habitat of koalas, and the koalas, they're going to die out if we keep doing this. And I pretty much said, if we continue on the path that we're on and we don't get rid of all the carbon and we don't move quickly, the koalas are fucked anyway. So Don't worry about them, mate. So I spoke to the Shadow Minister.
There's your episode title right there.
So I spoke to him and I said, transmission's important, a response to the IRA is important, and it'd be very, very difficult to make a case for what's effectively a pilot technology. And then 2 days later in the media, it came out that the small modular reactors in the US have been abandoned because they can't make a business case for it.
Yeah, the reason that it was given was that they just couldn't find any customers who were willing to pay the ridiculously inflated cost of energy that was coming out of the things, even after billions and billions and billions of dollars worth of subsidies. So, it's just proving itself to be the most ridiculously expensive, let alone, they've been working on that for 8 years, I think it was, and after 8 years, they've got to jump off the horse that's gone lame.
They should have just engaged Dr. Martin Green, Nigel.
What a perfect segue. What a perfect segue. While all of this hoo-ha is going on from the Liberals, we managed to speak to one of the grandfathers of industry recently, Professor Martin Green, who, has, as you'll hear in the interview, no less has been, recently granted awards by the King, amongst many other people. He's probably got more solar awards than anyone else in the world. And although he's sort of taken a little bit of a step back, he's still very much involved at UNSW, where a lot of that technology came out. We're also very fortunate to have Professor Renate Egan on, who is stepping up to the plate to fill in for much of the work that Martin was previously doing. Renate is both a founder of Solar Analytics and also a long-term industry stalwart, multi-award winning person. So, yeah, we had a great chat with Professor Green and Professor Egan. Why don't we take a listen? Well, today we're very lucky to have not one, but two of the most esteemed people in solar on the show, both from UNSW, from the Centre for Advanced Photovoltaics, I should say. Firstly, Scientia Professor Martin Green, winner of more than 28 awards. There's a Wikipedia page dedicated to, if you want to go and look through them all. Solar Hall of Fame inductee, responsible for the PERC solar cell, and perhaps most eloquently described by Chris Bowen recently as a national treasure. Welcome, Martin Green.
Oh, thank you very much.
Thank you for joining us. And alongside Martin is another famous person from the industry, Dr. Renate Egan, described as an innovator, an entrepreneur, and an academic, another Solar Hall of Fame inductee, another multi-award winner, co-founder of Solar Analytics, CEO of the UNSW Energy Institute, executive member of the IEA Solar Program, been involved in the PVPS forever. Renate, welcome to the podcast.
Thank you, Nigel. Great to be here.
Well, it's great to have both of you, and we'll get to why we've got you both on at the same time in a little while, and we'll also come back. It's been actually almost 2 years since I last chatted with you, Martin, on a previous podcast about where the PV industry was up to, and I think that's a really, really great topic for us to cover. But before we dive into that, there've been some changes at UNSW, at the Centre for Advanced Photovoltaics, and I wanted to explain to everyone what's changed there, because Martin's been known as the chief of solar down there, the king of solar, whatever, however you want to describe it, and things have changed a little bit. Question for either of you: what's changed and why?
I can answer. I'll have first go at answering that anyhow. So I started the Centre for Advanced Photovoltaics, combination of researchers at UNSW and other universities and CSIRO 10 years ago. But Renate was doing more and more of the work and arranged funding for the centre to be extended until 2030 nominally. And I thought it was time to step back and hand over the reins. So I classify myself as the founding director of the centre, but Renate is now the director.
Got it. Well, congratulations, Renate.
Yeah, thank you, Nigel. So it's important to note, yes, I have been sort of looking after the resource management and strategic directions and conversations with the industry and arena for the last couple of years, and secured the funding out to 2030. But I have been able to do it without Martin's support, and I'm relying on him staying involved technically for the remainder of the program and beyond, hopefully. So I'm looking after, the delivery of all the outcomes. Martin continues to be involved in setting the vision and the technical direction of the centre.
Well, that's a huge relief to everyone in solar, Mark, because we don't want you to go away yet. We need you to stay. So I'm glad. I was concerned that you were retiring and, you had, the old machines in the back shed or something, and you were going to go and mess around at home and we wouldn't hear. So that's great news.
So hang on, I'll just jump in there. For those that don't know you, Martin, can you give us a 5-minute or any length of time, a rundown on what it is that you do? Nigel didn't mention that you met the King last week, which is pretty amazing stuff. You're the first person that I know that's met the King. Congratulations.
Yes, I never thought I'd be receiving a prize from the King in Buckingham Palace. It wasn't on my bucket list because it just never occurred to me that might be something that happened. But myself, with 3 of my former students, were awarded the Queen Elizabeth Prize for Engineering for our development of the PERC solar cell, that's PERC, which, in 2021 and 22 accounted for about 90% of global production, but it is being overtaken by another of our technologies that we worked on even before PERC, and that's the tunnel oxide passivated contacts, which was our entree into the photovoltaic field, essentially.
For those that don't understand this stuff, Martin, would it be fair to say that improved the performance of the typical solar cell by a couple of %?
Yeah, so the last 5 years or so since PERC has been on the market, the efficiencies of the panels have improved quite markedly. So the best PERC panels now are, some are just over 21.5% efficient. That's the panel efficiency. The cells, of course, a couple of % more efficient than that. But we developed the PERC technology in our labs and got it to 25% efficiency around the turn of the century, and the industry sort of followed in our footpaths and got very close to the same type of efficiency. But so that's had one impact on recent cost reductions. That's been one factor. You can plot the data and show introduction of PERC probably approximately halved the cost of panels compared to what a business as usual scenario would have predicted.
Wow.
But the other thing that happened was some of my students, I can't really take credit for this apart from training the guys, got interested in, we had a spin-off company and the board wasn't too keen on us going into manufacturing and people were getting ADC and everything. So a couple of the guys on the team decided to try and set up manufacturing in China, which sounds something pretty easy to do. But back at the turn of the century, China had none of the infrastructure required for cell manufacturing. So Dr. Zhengrong Shi was first to do commercial manufacturing of the cells in China in 2002. He raised $6 million from local companies to do that. 3 years later, he listed on the New York Stock Exchange and raised $400 million, and overnight became the first solar billionaire. But that was really important in the evolution of solar cell costs because it caused an avalanche of US investment banks looking for other Chinese companies they could list on the US exchanges, and a rush of Chinese companies only too happy to get such a windfall cash injection. The competition between these cashed up companies is what really has given us the trajectory, towards the low costs that we've seen over the last 10 years.
I think that's just too small. It really undersells the incredible impact that UNSW and the work of you and all of the people at UNSW have achieved in turning the solar industry on its head so that we've now got the low costs that we have. And I know there's a million things that technologies and people and companies that have been spurned out of UNSW. So for all of those people in the industry that sell and install solar panels every day, take a moment to recognise the enormous contribution of UNSW and particularly Martin and his team. Before we dive into the tech a little bit more, I wanted to ask Renate, because I know funding has been a challenge for all academic institutions, and congratulations on extending the funding out into the future. That's awesome. You've got your hands on the steering wheel now. What's the vision that you've got for UNSW for the next 5-10 years?
Thanks, Nigel. We're funded largely by ARENA, the Australian Renewable Energy Agency. They've funded, Martin secured the funding, in fact, initially from the Australian Solar Institute, which was run by Mark Twaddell at the time. And that was then transferred to ARENA when it was established. And we've worked in partnership with ARENA for the last 10 years, and we intend to do so right through to 2030 on delivering new technologies and starting new industries or lots of new startup companies, training engineers and technologists of the future, because we continue down our path of essentially doubling the amount of solar that's installed every 2 or 3 years. And to do that, we need new technologies and solve new problems, particularly around grid integration, improve performance, reduce cost, and train the engineers that are going to deliver this technology. So that's that's the path we're on, and being led by Arena, who are really engaged with what we do. They set up an internal strategy, which they call 30-30-30, which is 30% efficiencies, 30 cents a watt installed by 2030.
Wow.
And they have funded the Australian Centre for Advanced Photovoltaics to deliver on that, plus set up another 5 or 6 projects, R&D projects, which are also delivering on that. And about half or more than half of which are run at University of New South Wales as well. So there's a really big momentum now around continuing to drive down the cost of solar to deliver on the downstream benefits that come with the panels becoming cheaper and cheaper, and to drive down the cost to improve performance and to do it with a 2030 timeframe. So really there's a lot more commercial or more industrial orientation to what we do, a little less blue sky research. We do still have the capacity to do that under our PhD programs, where our students have, licensed to dream big. But most of our sort of industry partnerships we have now are really focused on near-term outcomes. So, but the 30% efficiency comes with a blue sky challenge. We can do 30% on a small scale at a centimetre squared or so. We need to work on scaling it up. We need to improve lifetimes, and we need to drive down the cost. So that's all the sort of the motivation around that. And that's with the tandem technologies you've probably heard about, where you take the silicon bottom cell and you want to layer another cell on top that uses the parts of the spectrum that silicon doesn't absorb and draws the performance from that as well.
Beautiful.
Oh, it's one thing doing it in a lab, and then it's another thing doing it in production. I guess the satellite type solar cells are good for 40% efficiency these days, Martin?
Yes. We actually hold the world record for a solar module, and that's 40.6. But we use one of the space solar cells, which is a stack of 3 cells, but we managed to get a silicon cell into the stack as well. So it's a 4-cell stack that has given the 40.6%, world record module efficiency. But I think that type of efficiency ultimately will be what the industry is doing. But it's not going to be the next couple of years. It's probably at least 10 or 20 years off before you see those types of efficiencies in production. But we've done it in the lab.
That's incredible. It racks my brain every time I look at my own solar system, and I've got 390 watt panels, which were 2 years ago, and we're 50 watts higher than that in a regular mainstream, inexpensive, 35 cents a watt for a 440 watt panel now. It's just incredible. It's tough to see how we can get another 50 watts in the next 2 years, but I'm sure we'll have you on in 2 years and we'll be looking at a panel that's 500 watts.
No doubt at all. Here's your chance to really be a bit bullish about it. But if I'm not mistaken, there isn't another institution in the world that comes close to having achieved what the Centre for Advanced Photovoltaics has achieved. Am I right?
I guess in terms of practical outcomes, the way, the transformation of the industry was due to, our scholars. Most are now Australian citizens, but they're scholars from a Chinese background. I guess we've had a steady stream of them since the mid-'80s, and they're the ones that really triggered the transformation of the industry. And at the turn of the century, the Chinese stocks were really attractive on the US exchanges. So, it was sort of, I regard it as serendipity, but there was this US interest in stocks. Germany had introduced its feed-in tariff program, which was open to all and sundry, so they didn't restrict it only to German companies. And that provided a sort of a steadily growing market for these companies to feed into. So that, and having these highly trained students available and desirous of getting involved in cell manufacturing, it all sort of came together. Right people, right point, right time.
Brilliant. A left field question. I mean, the focus of the centre has obviously been on PV for obvious reasons. Is the centre looking now at the sort of potential for the next wave, for example, in batteries? Is that something that the team's looking at?
I'll let Renate answer that, but I'll just mention that the vanadium redox battery was also invented at UNSW. So that,
of course,
that was Professor Maria Skoulas-Kazokas. I apologise for my Greek pronunciation. Yeah, so I was involved in her in the early '80s, and I was interested in in the redox battery concept, and Maria had the idea of switching to all vanadium ions within that battery, which is what's made the technology viable. But I'll let Renate answer the bigger question after management sneak that bit in.
So the centre is funded with specific targets around 30% efficiency solar cells, 30 cents a watt by 2030. So that we have a really, we have a fixed budget and a tight focus. There are groups within the university that are working on batteries, on hydrogen or power to X, so not just hydrogen, but hydrogen derivatives as a storage and transfer mechanism. And importantly, there's a very strong team within the School of Photovoltaics and Renewable Energy Engineering that's looking at, it's called the Centre for Energy and Environmental Markets, and it's looking at markets and integration, which is, I think, one of the biggest challenges we have is integrating and transforming the market for distributed energy and encouraging the uptake of distributed energy resources and integrating that in our markets. I think that's really important, and I think I'm really happy to champion some, additional funding and resources going into that sector. But the centre itself is all about photovoltaics.
Gotcha. Okay, but some stuff around the edges, and no doubt as storage becomes ever more important, that may well bubble up onto the priority list.
Today might even set a few records in terms of distributed energy resources. So just quick whip around on the phone shows that South Australia is 99% renewable right now. Tassie's lagging behind at 20%, but Vic is at 65, New South Wales at 72, and Queensland at 60% renewable. So it may well be a record day across the country today for renewable generation.
And the rest of the world is looking on with interest. What we're doing, like literally, we have more solar per capita than anywhere else in the world, and it's more than half of it is on our home roofs. So it's just managing that, motivating that. Australians can be proud of our participation in this. And there's still this huge opportunity with commercial and industrial rooftops. We really need to change the thinking around that to try and open up that part of the market, because it's a real opportunity. I think solves a bunch of the grid problems if we can get more solar on those big rooftops.
I had this conversation with someone literally yesterday, and there's an enormous resource in our suburbs. We don't need to build transmission infrastructure if we can put it on a building next door. So I'm glad you raised that.
Yeah, here. And of course, let alone all the curtailed solar that we've got to find a way to unleash as well. Gigawatts and gigawatts of it that's sitting out there. Martin, I want to go back and you may or may not remember, but a couple of years ago when we spoke, you made some huge predictions actually about the cost of solar. It was 2 years ago, and you predicted that in about 3 to 4 years we would be probably heading towards a factory gate price of maybe 10 cents per watt for solar. I wanted to check in after 2 years and find out how are we going on progress towards that target.
Yeah, things got put on hold a bit with coronavirus, and that created some supply chain issues and everything, but we're back onto a very steep trajectory again now. So I just looked up the latest figures this morning, but this is sort of wholesale factory gate prices, but PERC modules now are 13 US cents a watt as of yesterday. So I think certain to get down to that 10 cents a watt, if not this year, certainly next year, unless we have another unforeseen intervention.
Another problem, yeah. That is just remarkable that, we're actually ahead of the curve as usual. You said 3 to 4 years, maybe 5, and here we are almost there after only 2 or so. So that's something else. And certainly I was chatting with someone the other day who was talking about the fact that Europe is flooded with stock, just absolutely flooded with stock as a consequence. And tell me what you know about this, but as a consequence of all the capacity coming back online and ramping up in China and everyone wanting to keep their capacity utilization rates as high as they possibly can to drive that cost down, the market consequence of that is they've been jamming a fair bit into warehouses in Europe from what we hear.
Yes, I can't claim to be an expert on the situation, but there's talk of all kinds of tariffs in Europe and so on. So maybe it's to preempt, getting the modules in there before they're liable for tariffs or something like that. That's helping to drive that trend. But
Yep.
Europe is very keen to re-establish its own manufacturing industry. After the experience with Russian gas, it's an international concern that China dominates the manufacturing, so strongly, which we're largely to blame for at UNSW. But it's had the benefit of giving us cheap solar, which I don't think we would have had otherwise. And it also means that China is installing a lot more solar than anyone else. Like 40% of the world's product is going into installations in China. And that's where you want the solar to cut down on greenhouse gas emissions. They have very ambitious programs to increase the solar input.
The other thing that was on the last podcast was you talked about the emergence of large format modules when we were talking about what the trends were in manufacturing. Certainly, anecdotally, I've seen plenty of evidence of that with manufacturers making ever more grandiose announcements about these epically huge solar modules. What have you seen happening in that space? Has that played out the way that you thought it might?
Yes, very much so. So a lot of the manufacturers, last year standardized on a standard large module size, and that's 2382 millimeters by 1134 millimeters. So I still think in the old units, 8 foot by 4 foot, so a massive module size, but that's not the biggest that's been made, but that's the standard size. So with the 1134 in the narrow direction, you can stack 2 packets of these modules on top of each other in a shipping container. So it sounds rather weird, but the whole dimensioning of modules and cells is being determined by what you can cram into a 40-foot shipping container. But if you go any wider than that, you have to stack the modules upright. You can't lie them flat in shipping containers, apparently, because that increases breakage rates. But you'd have to stand the modules upright, which some manufacturers are designing modules that they can do that. And then you've got 8 foot in the long direction and as wide as you want in the other direction.
The other thing that we talked about was, we talked about PERC, we talked about some of the other technologies that have been developed over the years. In the last 2 years, what's changed? What do you think is the next big thing? You mentioned the sort of heterojunction stuff. What's coming down the pipeline that's going to keep Renate and everyone else focused at UNSW with new technology?
Yeah, so the PERC has been the dominant one, but most new capacity going in is using silicon that's doped with phosphorus. Like boron was traditionally the dopant used that gives you P-type or positive type properties for the basic cell, but the phosphorus gives negative type properties, so it's the opposite polarity, and that modules using N-type silicon are capacity for those is being increasingly installed. So they're using one of our ideas, this tunneling oxide, which is what I did my PhD on, way back. But they're using tunneling oxide structure for the rear contact to those cells, rather than the PERC type approach, which is really based on small area contact between the metal and the silicon material. So the tunneling does the same thing. It allows you to make contact without getting extra strong electronic activity in the contact areas. It gives you a higher voltage. So we're going to see a transition from PERC to what's called TOPCon, tunneling oxide passivated contact, over the next few years. Mm-hmm. And then the other technology on the horizon is heterojunction technology, and we have a company here in Sydney, SunDrive, which is leading the world in the development of that technology. They held the world record briefly for a period last year. The first time Australia had held it since 2014. But that structure involves again using layers that are applied to the surface of the cell. The traditional cells, you introduce dopants into the cell to give the electronic function to the cell, but the better approach, it turns out, is to have external layers on the cell, and the TopCon is one step in that direction, and going to the heterojunction, both the top and the rear of the cell are contacted by, like external layers, and that gives you better voltage output than you can get with an approach like PERC.
So you've said a lot of things that I'm trying to just get my head around there. And so in simple terms, this is about coatings on the raw cell. Is that right?
Yeah. So, the way the cell's traditionally made up till very recently, you do things to the inside of the silicon wafer material. You introduce purity into that to control the
dopants
properties.
And we used to use we had a plasma machine as well that I think helped to deposit stuff inside the cells, right?
Yeah. So that's right. And, it's all about improving the quality of the surfaces of the cell.
Yep.
And introducing dopants into the material doesn't give you as good a surface quality as if you leave the surface untouched and apply layers to the top of it. You can't just apply any layers. And, this tunneling approach that we pioneered is one way of doing it. It uses polycrystalline silicon, which can withstand the high temperatures that are used in the screen printing of the contacts to the cells.
Mm-hmm.
But, back in the 80s, another approach was investigated using amorphous silicon. So, amorphous silicon was a technology in its own right that got used in calculators and so on extensively in the 80s and 90s, but was also, used for field installations that period. Just couldn't get up the efficiency above 10%, which, was a bit of a drawback in terms of the areas you needed, things like that. But that technology is used as the external layers that are applied in what's known as the heterojunction cell approach.
Yep.
And initially, our work at UNSW was referenced as the instigator of the thinking that led to that structure. Initially, they used deposited oxide layers to separate the amorphous silicon layer from the crystalline silicon wafer. But then they went to an undoped amorphous layer, very thin layer as a separator, and then a doped amorphous layer as the top layer. And now they've gone back in the highest efficiency devices to the oxide. So we feel we had some influence over that technology, although we didn't do any of the developmental work associated with it.
It's remarkable to me that after all these years, there are still, it sounds to me like there's still plenty of room for improvement, right? I mean, it's all these small things. And like you say, sometimes going back over ideas that you guys discovered years ago and just combining them in new ways. But there's still room for improvement.
Yes. So the limit on efficiency of a silicon cell by itself is somewhere between 29 and 30%.
Mm-hmm.
And the industry is working up to that. So, some manufacturers are claiming 26% efficient cell performance in production now. So, homing in on the 29. So I think the industry will get quite close.
Yeah.
And the other idea that, we battled Stanford University, like we held the efficiency record for silicon for 31 years, apart for a 6-month period when Stanford got ahead of us with this more complicated structure where both the contacts are on the rear. And SunPower was a spin-off from Stanford that has been marketing that product for many years, but it's always been a very expensive product. But now the industry is also looking at taking the cost out of that. So I think that'll be the final embodiment, because you don't have the shading of the top surface of the cell by the metal contacts. They're all on the back. Mm-hmm. So you get that extra boost in performance from that.
One last boost.
Yep.
I love it. We're rapidly running out of time, and I'm conscious that you and Renate are very, very busy people. But perhaps one last question to round it out. You mentioned SunDrive, who are doing some great stuff with, if I'm not mistaken, replacing silver with copper to help bring down cost, plus the other tech stuff that you mentioned. And of course, we've got Tindo in Australia, who are, by all accounts, our only real manufacturer and just expanded their facility. There's been a lot of talk about, managing the supply chain risks, about the growth that we need in Australia and the massive ramping up of installation capacity that we need to hit our our government's goals over the next few years. A question on PV manufacturing. I mean, of course, we'd all love to have more PV manufacturing here. Both of you have been involved in that over the years in Australia. Is it viable? Does it make sense? Can we manufacture more in Australia?
Thanks, Nigel. That's a good question, and we're actually doing a study on that now. So the Australian Centre for Advanced Photovoltaics, has been looking at costing of solar for a long time. As we develop new technologies, we need to cost how they might be, advanced or developed to make them cost competitive. So we've been looking at emerging technologies for ages, but we use the same modelling and metrics to develop an understanding of what it would cost for Australia to participate in the solar module manufacturing using current technologies.
Mm-hmm.
As we've demonstrated, we're working with China, and China, through vast investments, have demonstrated that you can drive down the cost of solar really substantially through scale and through performance enhancement, equipment improvements, and learning by doing. And having driven it down so low, I mean, Martin mentioned a moment ago, 13 US cents a watt is the current pricing on the PERC technologies. The question then is, can that same sort of thing be reproduced somewhere else in the world?
Mm-hmm.
And so we've been doing the analysis around that to see what the cost to do the same thing in Australia is and how big it would have to be in Australia to be cost competitive.
Mm-hmm.
And the challenge, of course, is that we're a relatively small market internally.
Mm-hmm.
And we think probably to reach the scales that we would need to be at to be really cost competitive, we'd have to invest at scales larger than our own markets.
Mm-hmm.
So it does look like that would be tough, but it's not to be cost competitive, right? But the reason that we would consider manufacturing locally is to de-risk a sole supplier risk. At the moment,
Mm-hmm.
all of the world is reliant on China for its manufacturing, and we're very grateful for the investments China has made. But if we're also going to anticipate a future where more than 50% of our power comes from solar, we need to be sure that we're going to be able to deliver that by accessing the modules when they're the volumes of modules that we need. So we're looking at it. We're looking all the way back to silicon refining to see where Australia can play in the supply chain. There's silicon refining, there's wafer ingoting and wafering, cell processing, and then module manufacturing. We're looking at that entire supply chain. We think that Australia certainly has a role in silicon refining at a scale bigger than our Australian market, which even now at 4 or 5 gigawatts, if that doubles again, say we're at 10 to 12 to 15 gigawatts, which is what we need to be to electrify everything and to have it powered largely by solar. Even at that scale, we could be exporting the silicon, the refined silicon. We could do ingoting and wafering. The cell processing is a possibility, but it's actually really need large volumes to get that prices down. And then certainly we could do moduling. And then moduling is interesting because it opens up other opportunities around glass and aluminium. So yes, I think there's a possibility, and I think we're actually talking to manufacturers who are interested because they want to diversify their risk as well. Even our Chinese colleagues with their big manufacturing plants in China are interested in opening up new markets. So yes, I think there's an opportunity, not without some vision and some government support. And if you look at why manufacturing has been successful in China, it's because they have had that vision and government support, a 10 and 20-year vision to say this is, we need energy. We need, to be able to supply it and deliver it. And they've invested with a 10 or 20-year vision. It's tough. If we had that same vision, we could do it.
Yeah, it's interesting. I mean, the manufacturing of the silicon's always been a highly energy-intensive process. So it stands to reason if you've got low-cost energy from renewables, that you can do it cheaper than someone that's doing it not from renewables. So I think that's got to be our angle. At least I appreciate there's still a lot of technology in making silicon, but if you can get that massive chunk of energy out of the manufacturing and replace it with renewables at a low cost, surely it's got to go close.
Yeah, that's right, Karl. It's true, and but it is an industry you have to do at scale. It's like aluminium refining. If we're going to do it, probably you could do it at 10 gigawatts equivalent, but 20 gigawatts would be more cost effective. So it's a really big scale. It's big chemical industry. It is, but we have retiring coal-fired plant, so we have facilities that can deliver the power and are available for this sort of industry. The green energy piece in Australia's, I know Martin's position on this is that Australia is really well placed to benefit from our solar irradiation, so that the low cost of energy that we can deliver by deploying solar rather than manufacturing solar. But we can bring the two together. So we can absolutely drive down the cost of energy through solar deployment and then leverage that to access things like silicon refining.
The wonderful irony of having developed the concepts behind all of this, exporting it to the world to get the cost of the technology down, which we've benefited from, that brings down the cost of energy, that makes us once again competitive on the global scale, is not lost on me. That is just the most wonderful example of how we can actually make this work. And we're sadly running out of time, but I really wanted to congratulate both of you, Martin and Renate, for the incredible work. I know you work tirelessly and often behind the scenes to deliver wonderful outcomes. So on behalf of everyone in solar, thank you so much for everything that you've done so far. Please don't stop doing it. Please keep going. Martin, you can't retire yet. We're keeping you around. Renate needs you. And the next phase undoubtedly is going to be seeing if we can get this manufacturing capacity back up in Australia over the next few years. Renate, Martin, thank you so much for joining us today.
Thank you, Nigel.
And thank you both, Nigel and Karl.
So there you have it, Professor Green, Professor Egan. If you haven't celebrated their achievements or looked into who they are and what that amazing mob of people at UNSW have been doing for decades now, check them out.
Another episode, Nigel, where I'm just beside myself with the amazing people that we managed to get onto this podcast. We're not worthy. And just stunning to have access to such amazing people for our show.
So true.
Any last thoughts you'd like to throw in there, guys?
I'll throw one in, a bit of a ruthless plug, but actually a bit of a step forward for the industry. As I've announced before, we are able to collect data from retail meters now to avoid the need for a consumption meter on solar sites, which saves time and money. We expanded that just last week, actually, and now can get data from about 90% of all the retailers providing customers with energy in Australia. So the consumption meter is dead.
That's pretty impressive, Nigel. So that works on a domestic meter as well. Is it real time?
It's not real time, no. It works on all meters, domestic and commercial. More targeted at domestic for sure. It's very simple. Customer who signs up to Solar Analytics who's got a compatible inverter will see a button pop up that says, "Do you want to add consumption data?" They click the button. It connects, they do a consent process, and the data starts flowing straight via API straight out of the retailer portal. So then they get that data. Like all retail meter data, it is day behind. So if you're a nerd or if you're a retired engineer, it's probably not the solution for you. You want live data, you want multi-channels, you want all those cool things. But if you're an average punter, day behind data is just fine. You still see live solar data. You get all your history, you get all the analytics, you get plan optimizer and all the other things. So for most people, it's a really nice alternative. A lot of people who are choosing it, a lot of retailers are excited because it's a very common scenario where the retail meter will be remote from the solar system. And then you've got to do a wireless comms or a cable or something like that. With this solution, you don't need to do that. You just whack the solar in, connect that up to the Wi-Fi, and then let the customer connect to the remote retail meter. So really nice on those sites where the solar inverter and the retail meters in different locations.
Awesome, mate. Well, thanks for joining us and listening. Luke will sign us off, but as always, very proud to be here.
We'll catch you next time. Thanks.